Radcliffe project looks like a, like a simple box from the outside, but then when you look, and take it apart, especially the structural CLT elements, it is quite complex.
CLT is a cross-laminated timber. It's made prefabricated in a shop, and essentially it's just layers of 2x material laminated on top of each other in a crossed orientation. So it actually has similar structural properties to concrete, but it's made entirely of wood. They're attaching the CLT to the crane, and the crane is going to lift that CLT and install it right in place. So right now it's the day 4 of 5, and we're actually putting the entire structure together.
The one thing I really like about the Pacific Northwest is like the amount of wood and the quality of wood that we have available. So we got, here we see more SPF, but those panels are 100% Douglas fir, locally sourced within, I want to say, a 2-hour radius from the panel plant. So that's good too. It doesn't make sense to ship wood around the globe and then bring it back as a finished product. That's happening right now. Wood also keeps its strength at high temperature. In terms of fire safety, those panels are far superior from a stick frame building. We use a melamine glue. It's compared to a PUR glue, it performs much better in fire, and it's green build certified. We had to do quite a bit of preparation work, so the whole house is already digitally built on a computer one. So every little block, every screw, every hanger, like every component in that house is in our computer model, and that allowed us to figure out all the details. And I believe that process forces us to think about it more ahead of the game. And so there is, basically working with the architects and the engineer, we build that house in the office, and then when it gets here, everything is figured out.
So every panel has been numbered and labeled, so we have a drawing, we have a model that reflects that.
These big panels get put in place, and then you can, put your weather barrier up, and then you can put your installation all around without stopping and starting, so to make sure that it is continuous.
So with the foundation wall here, it's actually wrapped with a Soprema that comes up and over, and the CLT sits on top of that with a sill gasket. So this is the exterior, and that's where you're going to put the SIGA membrane. That's the vapor open membrane. And on top of that goes additional exterior insulation. So as you can see, the exterior insulation will go straight to the corner, wrap around so that the corner has complete insulation around it. The membrane actually goes all the way up the wall, and because this here is a heated space above, the membrane will continue along. And that's the same thing with the insulation that goes up the wall. The insulation will go along the ceiling, and then all these joints and all the things will be taped and sealed. This is the inside wall, which we're gonna actually ferret out and put a service wall. So that way we can run all our services, that's electricity, plumbing, any other low voltage wires for speakers, as well as we have some hardware here. Not all the hardware is in right now, but there's gonna be additional structural hardware that keeps the CLT attached to the concrete. So that can be all hidden and behind this wall. And then with that service wall, I think this one's gonna be a 2x4 wall. It's gonna be filled with bad insulation, so we get that extra thermal performance. So this hardware, it's gonna get a lot more nails in it. This is currently just to hold it lightly. And then there's gonna be additional straps that go in to hold this all together. And then here you can see these are the actual electrical mains that are coming out from the mechanical room below. So that all gets hidden with the furring wall.
I was on site a few weeks ago, and then it all looked so effortless, but then I also remember that getting there, was a lot of planning, was a lot of shop drawing review, and then now that it is up, it looks like this box that fell into place like magic.